You deploy an AI to execute a global supply chain audit. It pulls vendor records, cross-references shipping manifests, and begins identifying bottlenecks. Then, mid-task, the session ends. The AI resets. The progress is gone, and it completely forgets what it was doing. Standard generative AI waits for you to type a prompt. It reacts to you. Agentic AI operates proactively, pursuing specific goals through a sequence of independent actions and tool calls. But these agents rely on a context window. You can think of the context window like computer RAM. It's volatile, temporary storage. The moment the token limit is reached or the session closes, the memory is wiped clean. Handing over access to your enterprise databases, APIs, and workflows to an autonomous system is a massive vulnerability if that system forgets your corporate security policies every time it starts a new task. To safely graduate from simple chatbots to reliable digital employees, enterprises need to build AI with a persistent cognitive structure, a system that actually retains information across sessions. Researchers mapped out a solution to this amnesia using the Koala framework, Cognitive Architectures for Language Agents. It structures AI memory into 4 distinct modules. First is working memory. This is the agent's immediate scratchpad. It holds the current conversation, active files, and temporary instructions within that volatile context window. Second is semantic memory. This acts as the reference rulebook. Using vector databases and retrieval-augmented generation, the agent pulls static company facts and security policies on demand. Third is procedural memory. This layer teaches the agent exactly how to do its job. It relies on specific markdown files that outline the step-by-step logic required to execute specialized tasks, like generating a compliant financial report. Finally, episodic memory provides compressed historical experience. The agent retains notes on past actions, what succeeded and what failed, so it can refine its reasoning in future sessions. Stacking these 4 layers turns an isolated, forgetful algorithm into a continuously learning reasoning engine. Equipping an agent with deep memory and access to external tools forces it to interact directly with sensitive legacy enterprise systems. This exposes the last mile problem. You now have non-human AI identities hitting your IT front door. They often use shared API keys or bypass standard authentication, leaving zero trace of which actual human authorized the action. An unmonitored agent with deep permissions is highly vulnerable. A malicious prompt injection could trigger a zero-click attack, causing the AI to autonomously delete databases or exfiltrate files. Treecapital Technologies engineered Anven AI to contain these risks. It operates as a sovereign intelligence layer. Anven deploys as a private, air-gapped large language model. It lives entirely within the enterprise firewall, guaranteeing that zero telemetry data ever reaches a public cloud server. It uses strict role-based access control, ensuring the agent only accesses data the human user is authorized to see. And by using edge-native inference via Executorch, processing stays entirely local. By acting as a digital vault, Anven ensures an agent's autonomous capabilities execute securely without turning into an uncontrollable liability. Running a fully secure digital workforce means you physically own the model and operate it completely independent of public cloud infrastructure. In healthcare, these localized agents synthesize thousands of patient histories and draft clinical notes while maintaining absolute HIPAA compliance, because the patient data never leaves the hospital's network. In finance, agents autonomously execute multi-step fraud detection workflows, cross-referencing sensitive transaction ledgers entirely within isolated virtual private clouds. For government and defense, teams parse highly classified intelligence directly on air-gapped, edge-native systems where consumer AI tools are strictly prohibited. Deploying autonomous agents securely requires a shift in infrastructure. You stop renting vulnerable tools from public cloud providers, and you start owning your intelligence as a deeply secured, sovereign digital asset.